Okay. As a layman, you can speak. I'm not specifically asked about.
Signals a wave.
Okay. Wait. And simple term, can you tell what do you mean by a signal?
Sir, a method to give a message.
Okay. Correct. Anyone else? So whatever all of you are saying, those
True or
things are
false?
correct. True or false? Great. Anyone else? Anything? Anyone else? Anything else? Any other definition? Or can you give an example? Simple example. Day to day life.
So a gesture or sound.
Yes, sound can be a signal. Yes, correct. Anyone
Sir,
else?
like a light signal given
Yes, light signal.
in
It can
scene
be a signal.
or to flight.
Great. Like you are indicating, suppose traffic light. So it can be a signal. Okay. Depending upon that, your vehicles are moving. So whatever all of you say, any other definition? Can anyone want to give?
Satellite.
Sorry, can you repeat?
Satellite.
I didn't get you. You're not clear.
The satellite means communication.
Okay, satellite
Yes.
communication. Okay. Satellite is okay. They are providing signals. No, I'm asking, what do you mean by a signal? So you are telling about the example. Okay. Anything else?
So it is a particular way of transferring the message from means one place to other.
Yes.
It can be
As
through the electrical signal or wave or any other.
yes, correct. So as you were saying, so basically signal means what? Whatever thing will have certain kind of information through which we'll be able to get some information which conveys certain information that will be called as a signal. Okay. So in layman term, if we'll speak, if something conveys some information, it gives us some information, then we can say that it is a signal. Like your car is moving on the road. So in a traffic post, you are in different colors. Your green color, red color, yellow color. Okay. So green color means what? You can move. Red color means what? It is to stop. Okay. Similarly, you are using mobile phone. Okay. So when a call comes, what happens? Your phone is ringing. The phone ringing means what? You are getting a signal that you need to pick up the phone. Okay. So signal means if it conveys certain kind of information, it calls as a signal. Okay. So is this point clear? First point, signal. What do you mean by signal?
Yes, sir.
Yes,
So
sir.
in simple term, if anything, it conveys certain kind of information or message, it is called as a signal. Okay. So signal are of many types. So now, if we'll restrict ourselves in in case of electronics, okay. So signal whichever is produced from an electronic component will be called as a electronic signal or electrical signal. Okay. When I am saying produce means it will in terms of voltage or current with respect to time. Okay. So basically, with the help of this electronic component, we are converting physical quantity into with respect to voltage. Okay. Now I am speaking. This is a physical quantity. If I'll convey it through a electronic devices, what will happen? It will convert it into a voltage level. Okay. Then the important thing is types of signal. Types of signal. So signal can be classified as many way. So majorly if we'll discuss, your signals will be of in general you can say, one second, let me share the screen. Is the screen visible?
Yes,
Yes,
sir.
sir.
Yes, sir. So signal, I can say that basically signal is of two types. Okay. Just I am saying you'll see more classification also. So basically we'll call this as analog signal and digital signal. Okay. There are other signals also. I am not going into that. Discrete signal is also there. Okay. So I'm restricting. It is not that I'm just restricting myself to this broad domain. So signals I'm classifying as two types. One is analog signal, one is digital signal. Okay. So as we already studied analog electronic circuit, okay. So this analog signal. So what happens in this analog signal? Here, so the signal which is continuous both in time and amplitude is called as analog signal. That means you can see here x-axis. What is I marked here in x-axis? What is there in x-axis? What I marked? Time. Y-axis it is amplitude. Okay. Suppose this is I marking 0. This is 10 seconds. Okay. So in between this 0 to 10, how many values are actually possible? In between 0 to 10?
Infinite.
Infinite possibilities are there. Infinite possibilities are there. Same thing for this amplitude also. Suppose this is 0 volt. This is suppose 5 volt. So here also infinite values are possible. This value can be suppose 2.1, 2.11, 2.112, 2.1123. So anything is possible. Okay. Infinite possibilities are there. So basically infinite means I will say that term, technical term as continuous. So a signal which is continuous in time and continuous in amplitude is called as analog signal. Okay. So all our real life signals, okay, whatever we are getting from the nature, all signals are this analog signal. Suppose I will measure the temperature. Suppose you will measure temperature in your room. Okay. Then how it will be? It will look something like this. It will look something like this only. Okay. So the signal, real life signal, everything is our continuous signal or analog signal. Is this point clear? What is analog? Is it clear? What do you mean by analog signal?
Yes, sir.
Yes, sir.
So signal which is continuous both in time and continuous in amplitude, it is said to be as a analog signal. Like I gave you an example, that temperature in the room. Okay. So I told you it is an analog signal. Okay. Now think little bit and tell me, is it really an analog signal? Is it really an analog signal? Can it take?
Sir.
Yes. So you are saying yes. Okay. Anyone else? Anyone else? Anything.
The question.
I'm asking, like I give you example of that temperature in a room. Temperature in the room. So I said that it is an analog signal. Okay. I'm asking, is it really an analog signal? Whatever definition I gave about this analog signal, will it satisfy? Will it
Yes,
satisfy?
sir.
Yes. Sir, I think it is continuous in time and amplitude. So I think it is analog.
Okay. So it looks like practically it is. Practically temperature can be anything. If we'll measure now, okay. Suppose here temperature is 40 degrees Celsius. I don't know. It can be 40, 40.1, 40.2, anything. Okay. So it seems like it is continuous. It is continuous in time, continuous in amplitude. Okay. Now, what is the definition of signal? Signal means what? Which conveys certain information. Signal means what? Something which conveys the information, which provides us the information. Okay. So can we measure? So ultimately to get that information, so real life temperature is this analog signal. Okay. This is infinite possibilities. Okay. But to get that signal for further processing, suppose you want to start the AC depending upon the temperature in the room. Okay. So how it will be decided? Depending upon signal it will be decided. If you are feeling hot, if temperature is more, then you will start your air condition. Okay. So for that purpose, you need to measure the signal. If you measure, can you measure that infinite combinations? It is not possible. Whenever you are measuring, you are not measuring the all values. Is it possible? Suppose you are observing a simple example. Suppose you are observing the time. Check your watch. Okay. What is the time now? Time क्या हुआ?
Sir, 12:16.
12:16. You are saying 12:16. Are you saying this is you are saying only 12 hour 16 minute? Are you talking about second? In second also further classified millisecond, nanosecond, picosecond, pettasecond. Everything is there. Why you are saying it is 12:16 only? Because you are measuring. You are measuring only in terms of minutes only. Yes or no? So actually time is continuous, but when we are measuring with respect to something. Okay. So depending upon that, there is another classification which is called as discrete. I will not go into that actually. Okay. Just I will give you example, only brief example. So actually real life signals are like in this example, temperature is an analog signal. But practically what is happening? When we are measuring, suppose same thing, you will measure the temperature with respect to time only. So how you will measure? Suppose after each 1 minute. Okay. So your time will not be continuous. Practically your time will not be continuous because you are not measuring continuously. You are measuring suppose after 1 second or after 1 minute or after 1 hour. Okay. So for that purpose, that kind of signals are called as discrete signal, which is continuous in amplitude and discrete. So continuous in amplitude and discrete in time. Okay. So signals will look something like this. Okay. So same thing, whatever is this signal, it is also same kind of signal. Only thing is we are not measuring continuously because we cannot measure. We cannot measure continuously. Okay. So this kind of signals are called as the discrete signal. Is this point clear? What do you mean by discrete signal? So discrete signal is continuous in amplitude and discrete in time. Discrete in time. So whatever you are measuring with the help of some measuring instrument, that signal will become a discrete signal. It cannot be analog. It cannot be analog. So real life signals are analog, but whenever you are measuring, it becomes a discrete. Okay. But what happens? Analog is very difficult to process. These analog signals are very difficult to process. Why? Because it is infinite, it is continuous in time, continuous in amplitude. So precise values are required. Precise values are required. So to solve this issue, what happens? We'll go for the digital signal. In digital signal, what happens? Precise values are of no use. We will not go for any precise value. Okay. We'll go for certain kind of ranges. Like we said that either it is on or off, or we'll say that it is true or false. Okay. Or we'll say that it is 1 or 0. 1 or 0. So digital, what happens? Actually digital signal is both discrete in time and discrete in amplitude. It is both discrete in time and discrete in amplitude. So that our processing will be easier. Processing will be easier. Like the same example, I told you to measure the temperature in a room. What happens? It can vary. Suppose it will vary from 30 degree to suppose 45 degree. So if you want to measure precisely, obviously it is a difficult task. Exact values will be difficult to measure. Now instead of that, suppose my processing depends that depending upon this information, I want to start my AC. Okay, I want to start my air condition. So if temperature is more than 35 degrees Celsius, then my AC should start. If it is less than 35, then it shouldn't be start, it will stop. Okay. So here, do you require the precise value? Precise value is of no importance. What is important? Important is whatever is the temperature, it is more than 35 or less than 35. That is our difference. So it doesn't matter. The signal is 30.1 or 30.11. What is important is whatever we are measuring, it is less than 35 or more than 35. So because of this reason, digital signals are widely used. There are so many reasons. This is the important one. Okay. Is this point clear? What do you mean by a signal? What do you mean by analog signal? What do you mean by discrete? What do you mean by a digital? So digital will only have two values, either on or off, true or false, or 1 or 0. Only two labels will be there. Is it clear? Up to
Yes,
this?
sir.
Give the example again for the AC one which you were giving.
So point was that, now the same example. If you want to measure from 30 to, suppose you are measuring the temperature. Basically, why you will measure something? What is the use of signal? You want to process something? If there will be no processing, then what is the use of just gathering a signal? There is no point of gathering any information. If you don't want to process, there is no use of getting the data. Okay. So now suppose you will measure from 30 to 45. 30 to 45. Okay. If I want minute details, that signal is 30.1 or 30.11 or 30.111 or 30.1111, does it really matters? It doesn't require. Why? I want my processing to be done like this. This information leads to this. I want to start the AC. If my temperature is more than 35, my AC should start. If it is less than 35, then there is no requirement. Okay. Then these precise values are of no use. What is my objective? My objective is only to check temperature is more than 35 or less than 35. So temperature can be 31, 32. Does it make any difference? It doesn't make any difference. It can be 31, 32, 33. But for my application, 31, maybe 31, 32, 33, 34. It comes in same range only. In that case, my AC will stop. So it doesn't matter what is the temperature. If it is less than 35, my AC will stop. If it is more than 35, AC will start. Okay. So this information, only important point is the temperature what I am measuring, it is less than 35 or more than 35. Okay. So what will happen? All these are not required. So what will happen here? Let me give you example. Actually, this thing will cover in the last chapter. So basically how to convert analog signal into a digital signal. Because as I told you, all the real life signals are the analog signals. But for the post-processing purpose, we need to convert analog into digital. Because it is easier if we'll go for the digital signal to process. So let us take an example. Suppose this is 0, this is 10. Okay, this is an analog signal. This is a analog signal. Okay, your time is continuous, amplitude is also continuous. So what I want to do here, I want to convert this signal into a digital signal. I want to convert this signal into digital signal. So you can see here already I converted y-axis into amplitude. It is already in the voltage form. Okay. So whatever temperature you will measure, that needs to be converted into this voltage range. So I'm not going into that. Okay. So now I want to convert this into a digital. So digital deals with what? It deals with only with two values, either true or false, on or off, or 1 or 0. Okay. So only two values will be there. Okay. So input range is supposed from 0 to 10. So if I want to convert this into these two values, either 1 or 0, basically what I need to do? I need to go for a range. Two ranges are required. So how can I divide the 0 to 10 into two parts? कैसे कर सकते हैं? How can we divide 0 to 10?
0 to 5.
Suppose I will take 0 to 5 one range, I will put in another range. So I will define, if it is 0 to 5, I will say that this is equal to false or off or 0. I am defining, okay. Now suppose 5 to 10, I will call this as true or on or 1. So for ease of just speaking, I will restrict myself now to only with 0 and 1. Okay. So 0 to 5, I will say that it is 0. 5 to 10, I am defining this as 1. So it is not mandatory. You can take reverse also. Okay. This is just an example. Okay. Then how to check? Now, suppose for that purpose, I need to take some time. Suppose these are the times. Okay. So start with time t equal to 0. Suppose this is 5 volt. Okay. So at time t equal to 0, what is your signal value? Signal value is this. So this comes in 0 to 5 volt range or 5 to 10 volt range?
5 to 10.
5 to 10 volt. If it is 5 to 10, that means what? This is logic 0 or logic 1? This range or this range?
1.
1. Logic 1. So again, I will define this logic 1 as, suppose logic 1 as, just for example, I will take this as 20 volt. Logic 0 as, suppose, 0 volt. Okay. So at time t equal to 0, what happens? It was 20 volt. So this 20 volt, which we are calling as logic 1, this will continue up to this time, next time. Next checking will be done at this time. Okay. Again here, what is the signal value? Signal value is this. So it is coming in which range? Again 5 to 10. If it is 5 to 10, what happens? Again logic 1. So logic 1 will continue up to this time. Okay. So just for example, I am not following the scale. Suppose this one. Okay. Now in next time, if the signal is this, what happens now? It is in 5 to 10 volt range or 0 to 5? It comes under 0 to 5. Means logic 0. Logic 0 means 0 volt. So at this time, this will change 1 to 0. Next here, again suppose 0. So 0 will continue. Okay. Now see here, now just compare these two signals, this signal and this signal. In first case, exact values were required, okay, for processing. Now, this one is simplified into this signal, which takes only two values, either 0 or 1, either 0 or 1. So processing will be easier with this case. If you only have two values, 0 and 1, it will be easier to process. Okay. As
So can
compared
we
to this.
say that rectangle wave is a digital signal?
Yes, it can be rectangular, or maybe this will be also, this can also continue. Okay, it is not mandatory that it will become rectangle only. Suppose it can be this also. Suppose every time this falls, the signal will be beyond suppose 5 volt. Then every time this will be in logic 1 only. Okay, so you cannot say that it is rectangle. Digital means it will take only two values, either 0 or 1. Only two values are possible. It can be perfect square, it can be a rectangle, okay. Any kind of waveform is possible. But whatever may be the waveform, it will take only two values, either 0 or 1. There is no intermediate values are possible.
Sir,
Yes.
if the signal is on 5, which logic will we take?
That will come later on. Okay, it is not about 5. It actually depends upon the actually basically what you are doing. You are doing this operation. This is what actually this is a comparison. Okay, so you will require a comparator for this. So for that comparator, you will require op amp. Okay, so in that op amp, it will depending on op amp, either it can be suppose 0 to 5. It can be more than 5 to 10. Anything is possible, either this or this. It will depend upon that op amp. So depending upon that op amp, this can vary. Is it clear?
Okay, sir.
So as you are a computer science student, okay, so you know why this 0 1 are preferred. In all your computers, you are doing work with with the help
Binary.
of
Computer
binary.
only understands binary.
It only understands the binary numbers. Why this digital? We only understand this digital signal, 0 and 1. Why 0 and 1? Because it is easier to process. It will be easier to process. So same thing. So again, same thing. Computers, you know, it is a basically a consists of two things only. It is a series of switches. So it has only two states, 0 or 1, or on or off, or true or false. So as we discussed that in this computers only understand binary, okay. But in our real life, we are not using binary numbers. What we are using? We are using the decimal number system. We are using decimal number system. So decimal number system means what? Basically, we are using from 0, 1 up to 9. We are totally using 10 digits. Because of that, it is called as decimal number system. And what is the base of this number system? Base is 10. Similarly, binary, what happens? Its base is 2. Okay. So what happens here? Here we are using only 0 and 1. Similarly, octal number system, its base is 8. We are using 8 digits. So what we are using? We are using from 0, 1 up to 7. Decimal, you already know, it is from 0 to 9, total 10 numbers, so base is 10. Next is hexadecimal, base is 16, base is 16. So what happens here? 0 to 15. No, not 15.
0 to
0 to
9, then 8,
then
A, B, C, D, E.
A, B, C, D, E, F. So remember, you can remember like this: A corresponds to 10, B corresponds to 11, C corresponds to 12, D corresponds to 13, E 14, F 15. Okay. So these are the different number system, out of which we will use this binary number system extensively. Okay. So same thing, binary number system use two numbers, 0 and 1. Okay. So next is how to convert any number system into into decimal, because we are comfortable with decimal. Okay, so let us first quickly see how to convert any number system into a decimal number system. So for binary number, what happens? We are using only 2 digits. So tell me
2 to the power.
any number, binary number. छोटा सा नंबर बताओ कोई भी, any binary number.
0, 1, 1.
1 से start करो.
1, 0, 1.
1, 0, 1. Okay. It is binary number means its base is 2. If you not mention means what? It is a decimal number system. In decimal only we are not mentioning. Nothing is mentioned means decimal. So binary it is 1, 0, 1. Okay. So I want to convert this into decimal. Okay. So what is the base of this number system? Binary number
2.
system? 2. Okay. So remember, this one is called as least significant bit. Similarly, this one is called as most significant bit. This is called as MSB. This is called as LSB. Like in decimal number system, we are calling LSD and MSD, least significant digit, most significant digit. Only thing is here it is converted into bits. So this is least significant bit. This is most significant bit. So here base is 2. So what will happen? You start from that right side. So whatever number is mentioned there. Okay. Another thing. Here it will have certain weights are assigned to each position. So the least significant bits weight will be 0. Okay. This will be, sorry, this position will be 0. This position is 1. This position is 2. So what happens here? This, as this position is 0, this will become 1 multiplied with 2 to the power 0. Next, this position is 1. So this will be 0 into 2 to the power 1. Finally, this most significant bit, its position is 2. So this will be 1 into 2 to the power 2. So what will happen? 1 into 2 to the power 2, 4 into 1. Plus 0 into something, 0. 2 to the power 0 into 1, 1. Total will be 5. So 101 in binary is same as 5 in decimal. Okay. So is it clear how to convert binary number into decimal number?
Yes, sir.
So quickly do it for this. What will happen?
So this is 25.
25. Why? Because this position is 0, 1, 2, 3, 4. So 2 to the power 4 into 1 plus 2 to the power 3 into 1. 0. So I'm not writing about zeros. 1 into 2 to the power 0, which will be 25. 16 plus 8 plus 1. Okay. Or you can also solve this directly. How? Here, this position is 0. 2 to the power 0 is 1. Position is 1 here. 2 to the power 1, 2. Position is 2 here. 2 to the power 2, 4. Position is 3 here. 2 to the power 3 is 8. Your position is 4th. 2 to the power 4 is 16. So just you need to check where you are getting 1. So we are getting 1 here, 1 here, 1 here. So just you need to add this. 16 plus 8 plus 1, which will be 25. Okay. So no need to solve this directly by writing like this. You'll be able to solve. So quickly, directly like this method, using this method, can you tell how much will be the value?
Sir, 102.
102. This will be 102. Same method. So quickly you can do. How? This is 1, this is 2, this is 4, 8, 16, 32, 64. Out of which 1 is present where? This one, this one, this one, this one. So 64 plus 32 plus 4 plus 2 will get us 102. Okay. So similarly, we can also able to convert octal numbers into decimal number. Same method with only one change. Here we are used to do 2 to the power position number. Here base is 8. So you have to go for 8 to the power position number. Okay. Suppose your number is, octal number is 127. 127. Then what will happen? This will become, this is position 0, 1, 2. So what will happen? 1 into 8 to the power 2 plus 2 into 8 to the power 1 plus 7 into 8 to the power 0. So how much? This is 64, this is 16, this is 7. So how much? You will get this as 87. Okay. Exactly same way we can convert hexadecimal number also into decimal. What to do? Now same example, only thing is this 8 will be replaced with 16. Okay, exactly same method. Okay, and A to F we already told. A is 10, F is 15. This from 10 to 15. So accordingly you can put the weights there. Okay. So similarly, one second. So next is 1111. Can you tell this binary number how much will be the decimal value for this? कितना होगा?
27.
No, this is binary.
15.
This is not 15. This is 1, 2, 4, 8. All are 1. This will be 15. Now suppose I will put dot 1 1. Okay. Then what happens? After this dot, this position becomes -1, -2. Okay. This position becomes -1, -2. So exactly same method. This is the only difference. 2 to the power minus 1 is how much? This is 1 by 2. 2 to the power minus 2 is 1 by 4. Okay. So क्या होगा? This 2 will be added. 1 by 2 plus 1 by 4. How much you'll get? 1 by 2 plus 1 by 4 at 15.75. Exactly same way you can do for this octal number and hexadecimal numbers. Okay. Next is just the opposite. How to convert decimal number into binary, octal and hexadecimal. Okay. Now suppose number is 13. I want to convert 13 into binary. Then what to do? For binary, what is the base? What is the base of the binary number system? 2. So we need to divide it with 2. So what you will get? 2 into 6, 12. How much will be the remainder?
One.
Then again we will divide with 2. So 2, 3, 6. Remainder is 0. Then 2, 1. Again remainder is 1. Then 2, 0. Remainder is 1. Okay. Then what we will do? We will arrange this from bottom to top. So 13 in decimal will equal to, from bottom to top, what will happen? 1101. 1101. Okay. Same thing you can see here. Example of 56 is also given. Okay. So 56 will be how much? Check this and tell. How much will be 56 in binary? This will be 1, 1, 1, 0, 0. Okay. So if this number is small, then you can follow this method. Now suppose I will write, instead of this, I will say that find this number 1, 2, 3, 6, 9, 5, 4. Again, it is possible, but in a pen and paper, is it possible to keep on writing and dividing by 2? It is possible, but it is difficult. Yes or no? It will be lengthy. Yes or no?
Yes, sir.
Yes, sir.
So at least you should be thorough in this, how to convert binary into decimal and decimal into binary. So again, we will go for a shortcut. Okay. What is shortcut? Shortcut is just the, whatever we have done here, it is just the opposite. How I converted this number into decimal number? Basically what I did, I put those weight, this position is 0, so weight was 1, this weight was 2, this weight was 4, this weight was 8. Then we added all things because all were 1, so we got that this is equal to 15. Similarly, another example, suppose this. So what happens here? This weight is 1, this is 2, this is 4, this is 8, this is 16. Okay. So what happens here? This is 1, this is 1, this is 1. So 16 plus 4 plus 1. This is 21. Okay. So exactly same thing you can do again. Exactly same method you can follow here also, only in reverse order. So now suppose 56 I want to find out. So what I need to do? I need to represent this 56 as a sum of that 1, 2, 4, 8, 16, 32, 64. If I can represent like this as addition of these numbers, then my problem is solved. Okay. Now observe this and tell how much will be 56. Do I require 64?
32 will be the start.
No, sir.
32.
Till 32.
Then 16. 32 plus 16, 48. Then 8.
8.
Will be 56. Okay. So for 36, what to do? So for this 56, 1, 2, 4, 8, 16, 32. Okay. So here, in this position, what to write? 32 is present here, so 1 should be there. 16 present, 1 should be there. 8 present, 1 should be there. 1 is not present. So all this should be equal to 0. So we'll get 111 000. Okay. Now, suppose I want to represent 57, then what to do? 57,
I will take 32 and 16
32 plus 16 plus
plus 8
Plus one.
plus 1.
1. Okay. Again, 1, 2, 3, 4, 5, 6. This is 32, this is 16, 8, 4, 2, 1. 32 is present. 1.
1 1 1 0 0 0 1.
So this is the easiest one. This is the easiest one. Using this method, you can convert decimal number into binary number. Exactly same way you can convert decimal number into other number systems also. You can go through this, how to convert this into octal. So instead of dividing by 2, we need to divide by 8. Similarly, in case of hexadecimal, we need to divide by 16. Okay, exactly same method. So only thing important is remember this method, how to convert. How to convert, at least you should be thorough how to convert decimal into binary and binary into decimal. Okay. So same examples are given. Okay. Again that decimal number into binary number. Okay. So this is after the 0.479, what to do? Like in the previous case, for this one we are dividing, whereas after this point we need to multiply. We need to multiply with 2. So what will happen? Suppose I want to convert 15.479. I want to convert this into binary. Okay. So what I will do? I need to convert it separately. 15 will be converted separately. This 479 will be converted separately. So how much is 15? 15 क्या होगा? 15 is how much?
Sir, 1 0
8 plus
4 2 1.
4
4 plus 2 plus 1.
plus 2 plus 1.
Okay. So if I write 8 4 2 1, all will be 1, 4 ones. So 15 is nothing but 4 1. Next we need to see for this point 479. So here what to do? We need to multiply this with 2. So 0.479, you can check, I am not writing again. 0.479 into 2, you will get as 0.9850. Okay. So I am writing here as 0. This 0 I am writing here. Then next is 0.9850. Again this will be multiplied with 2. So how much you are getting? We are getting 1.9160. Okay. Again 1 I will write here. Then remaining portion 0.9160, it will be multiplied with 2. It will be multiplied with 2. You will get 1.8320. So again I will write 1. Remaining is 0.8320. So if we multiply with 2, it is 1.6640. So again I will write 1. So as you can see, it is, I am not getting 0, so it is not stopping. Okay. So previously what happened? Here we used to take from bottom to top, but here it is opposite. Here it is opposite. Here we have to go from top to bottom. So this 0.479 will be 0.0111 and continuing. Dotted means continuing. It is not stopping. So what will happen to 15.479? This will be 41.011. Continue. So these are the basics just for information. Okay, these are not required, just for basic information. Same thing here also. If you want to convert this into octal, instead of multiplying with 2, you need to multiply with 8. So up to this, is it clear how to convert?
Yes, sir.
Next is how to convert binary into octal number system and hexadecimal number system. So let me first write 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now, if I want to represent 7 in binary, okay, this is decimal number. I want to represent this in binary. Okay. So what will be the equivalent of 7? 7 क्या होगा? 1 plus 2 plus 4 plus 8 कितना होना चाहिए?
1 1 1.
It must be 4 plus 2 plus 1. Okay. So 3 count bits will be 1. 6. Sorry. 6.
1 1
110.
110. 5. 101. 4. 100. 3. 011. 2. 010. 1. 001. 0. 000. So it is not a magic, it is simple trick only. Okay. This weight is 1, this weight is 2, this weight is 4. So depending upon requirement, I am adding and putting the ones only. Suppose I want 3. 3 must be 2 plus 1. That's why this is 1, this is 1. Okay. So now suppose a binary number is given. A binary number is given. If I want to convert this, into octal number, okay. Octal, what happens? We are using 0 to 7 only, and its equivalent binary number I already wrote here from 0 to 7. So if you want to convert binary into octal, what to do? You need to form a combination of 3 bits. So this is the dot. I will make this as 3, this as 3, this as 3. After this dot, 3 digits are there, 3 bits are there. This will be 3. So first check here, 001. What is the equivalent of 001 here? 001 कहाँ पे है? 1. So this is 1. 010. This is 2. This is 2. Next 111. 7. Dot 100. This 4. This is 127.4. Okay. Now suppose see this example. Here, after dot, we need to form group of 3. This is 3. This is 3. This is 3. But now single is remaining. So what to do? We can add 2 zeros.
Add 2 zeros before.
So 001 equivalent is 1. Again 001. Again 1. 010. 2. 111. 7. 7. Point 01 again 2 numbers. So I need to add another 0. 010. 010 is 2. Okay. So in this way you will be able to convert binary into octal. Okay. And also octal into binary. Suppose a octal number is given 236. Octal number. What will be its binary equivalent? What is 2? Check this table and tell. 2
0 1 0
1 0 1 0 3
0 1 1
0 1 1 6
1 1 0.
1 1 0. This is the binary number. Okay. Once you know binary number, suppose you want, you can convert this into decimal also. Okay. So in this way, you will be able to convert binary into octal or octal into binary. Similarly, what will happen for hexadecimal? Hexadecimal is 4 bits. Like in octal, 8 digits were there. In hexadecimal, the number of digits are 16. So what to do? 7, 8, 9, 10, 11, 12, 13, 14, 15. So I want to represent up to 15. So first of all, how many bits are required? Basically, we need to represent 15 as an addition of 1, 2, 4, 8, 16. Do you require 16?
No.
Not required. So up to this will be sufficient. How many numbers are there? 4. So 15 is what? 8 plus 4 plus 2 plus 1. So all are 1. 14. 8 plus 4 plus 2. Okay. ठीक है और कुछ करते हैं. Suppose 5 क्या होगा? What will be 5? Just weight is nothing but
1010.
10. No, गलत हो गया, 10 नहीं होगा. देखो पोजीशन क्या है?
0101.
0101. Suppose 10. 10 क्या होगा?
1010.
1010. 10 is 8 plus 2. So those position 1 will be there. 7.
0111.
0111. Okay. So at least out of all those things I taught, at least keep this thing in mind. At least from 0 to 15, this conversion should be, you should remember. Okay. Either remember or you should do in this manner, but we'll require later on about this. Okay. So each time we need to write this. Okay. So you should be thorough in this. So एक एक करके इसे लिखना नहीं पड़ेगा. Okay. So again I am changing, just I am writing, you just verify it is right or wrong. Okay, so these are the conversion of from 0 to 15. Okay, so just take an example of this. If you want to convert binary number into hexadecimal, you need to form the combination of 4 4. So this is 4. This is another 4. This is another 4. This is another 4. So what is 1011? 1011 is this.
B.
This is 11. 11 means what? A is 10, B is 11. So this is B. Then 0110, 0110. This is 6. This is 6. अरे रह गया 1 सेकंड. 0101 रह गया ना बीच में. ठीक है 6 का उल्टा कर दिया मैंने. ठीक है. 0101 5. 0101 is 5. Check here. This is 5. 41 is this 15. F. 41 is 15. F. 15 is nothing but F. Okay. So this is B6 5F. Same thing. If sufficient numbers are not there, in this example you can see this is 4, this is 4, this is 2. So you need to add 2 zeros here. Similarly, to write up this, 3 numbers are there, you need to add a 0 here. Okay. Okay, let us stop here. Next class we'll see. Okay, same table is there. Okay. Next class we'll go for the addition and subtraction. Okay.
Sir,
Yes.
sir, can you send today's slides in the group?
I will send.
Okay, sir. Thank you.
1 second, let me take the attendance. After that you can leave. Don't leave the meeting.
Yes, sir.
Don't leave the meeting. I have not taken the attendance yet. I am taking. Thank you very much.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.